All right, so all of this that we just learned works for logs, log base 10. The same thing works for log natural logs. Okay? So, I'm going to write it over here, then I'm going to organize it. So, ln, okay, ln x is equal to log base e of x. Okay? So we have to know that ln x is equal to the log base e of x. Okay? So that's nice and clean. So I can say, hey, if ln x, then it's the log base e of x. Right? Okay. What else do we know? Well, obviously, if we go ln of 1, what is ln of 1 going to be? So we might, since you guys looked at me like, huh? We might want to write that down, right? ln of 1 is equal to what? 0. Good. Nice. Yes. Easy, right? ln of 1 is equal to 0. If ln of 1 is equal to 0, then what does that mean? That means e to the 0 power is equal to 1. That's all. Does that make sense? Okay? All right. Now I just realized something that I forgot to show. Log. So I'm going to show it with ln. Okay? They always show it with ln. Okay. ln of e is equal to what? So let's think about that. Let's just, for right now, let's call it x. Now, what's the base? What's the base of ln? No, remember?
Oh.
It's the base e, right? So e, right, raised to the x power, right, is equal to e. So what does x have to be? For e to equal e, x has to be 1. Does that make sense? Right? So for e to equal e, x has to be 1. So that means that ln of e is equal to 1. If that's true, then is it log of b base b equal to 1? Any log with the same base of the number, wouldn't that equal 1? Think about that for a second. So I'm saying log base b of b, that equals 1. That means, let's put these in colors. The green b, so green b raised to the 1 is equal to the blue b, right? Does that work? Is that right? B to the 1 equals b. Right? So 5 to the 1 would equal 5, right? 6 to the 1 would equal 6, and so on. Right? So those are huge rules right there. Okay? So those are big time rules. Okay? But those aren't the rules I was coming up here to teach. Now we got to teach all the exponential rules. The fun ones. Okay? Alright, here we go. When we take two powers and we multiply them, what do? When we have x squared times x to the fifth, what is that? X squared times x to the fifth, what is that?
Like 2x to the power of 7.
no, not 2x, but x to the power 7. So we added the exponents, right? Okay? You added the exponent when you multiplied the powers, right? You added the exponents, right? What is a logarithm? It's an exponent. So when you add logarithms, you multiply their powers. Does that make sense? So when I take my logarithms, log of x plus log of y, that will equal, when you add exponents, what do you do to the powers? Multiply them, right? Boom. And that goes both ways. And that goes both ways. So when we line it up here, we're going to say if, it's purple out, if log x plus log y, then, and it goes both ways, then log xy. Does that make sense? Because when you multiply their powers, you add the exponents, right? Logarithms are exponents. So if we add exponents, we're going to multiply their powers. Okay? What else do we do when we divide? When we divide powers, when we have x to the 10th divided by x to the 5th, or let's say x to the 3rd, what do we get? Right? If we get x to the 10th divided by x to the 3rd, we get x to the 7th. What did we do?
Subtract.
We subtracted. So what do you think you do when you subtract logarithms? Yes. So if I say log of x subtracted by log of y, then what am I going to do? Divide. Then log of x divided by y. This is huge. I love logarithms. Love it. Okay? Alright. So, if log x is subtracted by log y, biconditionally, log x is divided by y. Does that make sense? Kinda? A little bit? Better than it did yesterday? Since you've never even seen this before, right? Okay? Good. What other powers do we have? Right? Power of a power, right? Power of a power. What does that mean? You're like, power of a power? Well, x to the 10th raised to the 3rd. What is that?
Oh my god.
You add?
No? You have 3 of those 10s, right? So you could add 3 of them, or you multiply, right? That's what you said? Multiply?
Yeah, that's why I hate them, because it makes it hard.
Okay? So we have to remember those rules, right? So if we're going to multiply, when we have a power of a power, then what are we going to do if we have a power inside a log? We're going to multiply. This is the hardest ones for students to get. Believe me. But it shouldn't be, but it is. So, log of x to the a, okay, is equal to a times the log of x. So I just take that and put it out front. That's it. Because I'm taking a power within the exponent, right? Within the log. So a power of a power means to multiply, so I can just put it out in front. Okay? So, if I get log of x to the a, then I get a log x. Now, do you think all of this works if it's ln, 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 L, right? Of course it does. Both logs work the same way, okay? They just have different bases, okay? So you're talking about a log base E compared to a log base 10. They're the same thing, okay? So treat all of your LNs the way you would logs and you'll be fine. Okay? I think that's it. Oh, one more. Oh, a couple more. Okay. So, is that still going?
Yes.
Okay. All right. So, we
Same, Dad.
it's.
My life.
I don't think these ones are necessary. Okay.
Nice. You got that on phone? What? Happy
Okay, so those aren't necessary. That's just talking about changing bases. I don't need to change bases. Maybe we do. I've never seen this rule, but maybe in pre-cal you might use it. So just so you have it, you know this rule that we made to get to 10 right here? To go log base 10 of x over log base 10 of b. I guess you can do that to any, it makes sense now I think about it. You can change it to any base. So let's say on the other side of your equation you had base 3. Okay? But I would just change that to base 10 and then, well, you know, that's just a longer way of doing it. But you could say that log base b of x is equal to log base 2 of x over log base 2 of b. The reason why we make it 10 is because then we can put it in our calculator. I don't know why you would want to make it 2, except maybe if this is equal to log base 2 of something, but I would just change that to a log base 10 over log 2. So I don't know why they would do this, but that's just something that they're throwing at you. And the other one that's funky is log base b of b to the x. Log base b of b to the x. I've really never used this myself. Okay? Is equal to x. And then they say, well, why? Well, pretty simple. B to the x is equal to b to the x. Does that make sense? So again, I think this goes back to our rule here. Okay? And our rule here. Why we came up with 1. Now this is important. This is going to be used a lot. I never really used this, and I never used the other one, so I'm not going to include them, but because they're in your book, I'll put them in there. But basically what it comes down to is, there's your notes. I think you can do anything with that. Okay? And then when I say any